Hi there, my name is Jacob and I'm an environment artist for Quixel at Epic Games. This is the third part of our extensive tutorial series about our medieval village demo project. After diving into the new geometry tools introduced to 4.26 in the previous tutorial, we will now look at adding the necessary roofs to our houses. Specifically, we'll go over how exactly we used the sculpting functionalities of the new geometry tools along with Quixel Mixer and our Atlas scans to create unique setting-appropriate thatched roofs. The entire project is available on the Unreal Engine marketplace for free for you to download and dive into. Just as before, let's quickly remind ourselves that the broad vision for this project was that of a rundown, dirty and disheveled fantasy-esque village with a few small huts and housings. Therefore, we need to make sure that our roofs fit into this old abandoned look too. Especially with thatched roofs built from hundreds of thousands of individual wheat and grass straws, this can be a rather tricky task, even more so when targeting real-time visuals. So, without any further ado, let's jump in. We decided to approach the roofs as two different parts of a puzzle. One would be the underlying base mesh, providing us with the necessary base shape of each roof. On top of that, we then place individual thatched cards created from reassembled Atlas scans. This will give our roofs the fluffy and disheveled look of individual strands. Let's start with our base mesh. Using simple primitives from the geometry tools menu, usually boxes, I started out blocking out the rough shape and thickness of the roof following the previously built house structure. Once I was happy with that, I then simply merged the blockout shapes and retopologized them, giving me dense and even geometry to work with. Using the sculpting tools, namely the dynamic sculpting, I could then start to alter the shape, smooth corners and make this feel more organic and heavy. Depending on what I'm after, whether it's creating smooth mesh shapes or adding actual detail, I preferred leaving the sculpt retopologizing option in the sculpting menu on or off. Generally, at this point, I wasn't really worried about poly count at all. To me, it was only really important that I'm able to create good shapes. Since we won't be seeing the underside of the roofs, deleting inward-facing or obstructed polygons will free up much needed UV space. Using the triangle selection brush makes this task very efficient, even more so when using the optimize selection functionality to automatically clean up our selection. To give me better texel density and control over a structured UV layout, I exported the final roof sculpt and re-UV'd it. Once my UVs were all sorted out, I brought the mesh into Mixer and simply applied a previously created thatched smart material that made use of a few of our Haybel scans. While not using real-time displacement and tessellation in Engine for this project, having displacement information gives us the unique opportunity to displace and reduce our mesh using the new geometry tools. So, in Mixer, after a few tweaks to the material, I made sure to enable displacement in my export settings and then simply exported all of my maps with a simple click of a button. Back in Unreal Engine, I could then use the displacement map to add interesting and natural variation to my base mesh. I pushed for more extreme values in the Geometry Tools Displacement tab to ensure that the base mesh carried enough detail to blend in with the high-frequency thatch detail we'll be adding later on. Happy with the result, I could then finally reduce the poly count to something generally more acceptable for real-time purposes. Now, keep in mind that you can always use the non-destructive and extremely powerful reduction settings in the static mesh editor, so I only used the destructive reduction settings of the geometry tools to get me closer to a reasonable poly count ballpark, which gives me a bit of wiggle room to adjust poly count further down the road. Given the high geometry density of our base mesh, I made sure that my generated LODs are quite aggressive, as I only really want to render the large amount of polygons when actually necessary. You can do this directly in Unreal Engine in your static mesh editor. With our base mesh done, it was finally time to add our Thatched Cards. These are simple geometry planes modeled on top of rearranged atlas scans found in our Megascans library. We essentially have 3 basic sets of different atlas styles varying from dense, light and very scraggly variations. Now for this we used a custom Houdini tool which allowed us to very quickly and dynamically rearrange atlas cards, but this can also be done manually just straight in Photoshop. While you could definitely place these in a DCC like Houdini with more custom and procedural one-click solutions, it was very important to me that we'd have maximum control over card placement. So in our construction level, rather than just automating the entire process, I made sure to place each and every card by hand. Admittedly, this is quite a strenuous and monotonous task, however it gives us the necessary artistic control over how our cards appeared in engine on our roofs. Now, this method of card placement or thatch creation on its own is quite the expensive draw call heavy method. However, we'll be able to rectify that by merging them down after the project is done. My colleague Matt Osterley will go way more into detail on performance optimizations, also covering the roofs in his upcoming tutorial on this medieval village demo project. Last but not least, let's take a look at how we used what we have learned about the new geometry tools to push asset creation in Engine even further. One very handy workflow this toolset allows for is using scanned atlas or 2-dimensional scans to create unique 3D assets. In this specific case, I selected an atlas scan of a wooden hedge using the displacement functionality with the provided displacement data on a simple plane to push out the vertices until I've gotten a 2.5D mesh. All while staying in Engine, I could then duplicate this high poly, properly reduce it to a low poly base and bake out a new normal and AO map. To push this further after a bit of cleanup, I made sure to mirror the result in order to create a closed mesh, then bend the asset roughly around where the hinges are located. Within a few clicks, I just created a unique, game-ready low-poly window shutter from a single scan that holds up compared to our other assets in this scene. With our roofs and additional pieces finally done, we can also call our buildings done and start concentrating on other aspects of our environment such as set dressing, foliage as well as lighting and atmospherics. Now, thank you all so much for watching, I really hope you enjoyed it. We'll cover how we implemented and set up all of our foliage in preparation for the final scene assembly in the upcoming tutorial, so make sure to advance to the next part. As mentioned before, you will find all tutorials of this series listed in the description below. Please feel free to drop your questions or thoughts into the comments and, as always, I can't wait to see you in the next one.